Modules and ports. This is the second portion, second part of the second module. Okay, this is also very easy. Okay, whatever you studied the programming and the Verilog HDL law, that used to be explained. Okay, in the words, what are the parts of the programming? Okay. This is the second part of the second module. This is the modules and ports. Modules and ports. What are the modules? Modules means what? This is the skeleton of writing the Verilog HDL. This is the skeleton of writing the Verilog HDL programming. There are four types of modules. One is what? The first one is what? Manju. Yes, tell me. There are four types of modules in the Verilog HDL. Which are those? First one is what? The data flow model. Data flow model ಯಾವುದು? Second one is the behavior model. Third one is the gate level or Salahuddin. नहीं सुनता रहे? You can leave the classroom. Just go outside. If you want to sit, sit quietly. Otherwise, you can leave. Okay, gate level model. Another one is what? The switch level. Switch level. Okay, these are the four types of writing the programming model. Okay, one. Okay, each these one we have the different. Okay, which will be different from one another because based on what? The abstraction level. Based on the abstraction level. If I consider the writing of the program, any one model will have the same skeleton also. The skeleton of writing the programming will have the some standard qualities. Okay, some standard parts. You have to define the whatever we want to define the ports and all. We should have to define the before the writing of the any programming body and all. We'll have the some model as it is for writing the program. Okay, for writing the program, I should have to define the always start with the module. Okay, always start with the module and also I have to end with what? The end module. Okay, this is what the starting of the my writing the Verilog HDL program with the module and the end module. Okay, I have to immediately after the module I should have to define the module name also. Module name. What are the module name can be not a okay your choice. Okay, it's based on your the what type of programming you are writing. Okay, you come here. Mustaki, come here. Come here. You sit properly, otherwise you can leave. Come here, this side. Come here. Come here. Okay, these are the model and also end model. Okay, I have to follow it now. Immediate following the model name. I have to define the ports also. Model after the ports also. Ports are nothing but the inputs and outputs here. I have to define the inputs and outputs here, and also I have to write the body here. Whatever the define. This is the skeleton of writing the Verilog HDL. Inside this one, what are the these are the what is this one model? This is the model. This is the what the model name and also ports. Like this, I have to end with the model also. That one only we have the model. Here the model is the basic building block of our writing the Verilog HDL. How it is to be done? Always start with the model model name, port list, this is what the header part in the writing the Verilog HDL programming. I have to write the in the header part as the model name and also port list. That's nothing but the input and output, and also port declaration. If it is necessary, only you have to define the port declaration, and also parameters also optional. These two are the optional. The compulsory is what the model is the model name, model with the model name, and also port list is compulsory. These two are there. Okay, you should have to, whatever we are writing, whichever the programming, where like HDL, these two are the important. First one is the model with the name of the model, and also port list are these two are the compulsory. And port declaration, parameter declaration, these two are the optional. These two are the optional. Okay, and also end model. Huh. End model statement is the end of this following this one. Okay, inside, okay, between these two I have to write, I'm writing the body. Okay, whatever I'm writing, this one is the about the declaration of fires. Here what we are doing there, declaration of fires, declaration of fires, and also registers other variables also. Just to copy this one, that's the figure of the components of the Verilog model. They will ask in the examination for 10 marks. Okay, write a Verilog components of the Verilog HDL model and also explain in briefly. Okay, in detail they will ask for the 10 marks. This is the fixed question in the fourth question in the examination. Okay, in your question paper they will be asking this type of this is the one of the fixed question in the examination. They will ask for the fourth question, not in the third question. They will be asking in the fourth question of your question paper. Okay. Hey, bah, get up. Come, stand here. Come here. Come here. First class here. Mundu kurogu. Mundu kurogu. ಸುಮ್ ಕೊಡ್ಬೇಕು. ಇತ್ತದ್ ಕೊಡು ಪುಸ್ತಕಿ ಪುಸ್ತಕಿ ಬಿಸ್ಸಿಟ್ಟೆ ಇತ್ತದ್ ಕೊಡು. ಆ ಸೈಡ್ ಇಡು, ಆ ಕಡೆ ಇಡು, ಬ್ಯಾಗ್ ಆ ಕಡೆ ಇಡು, ಈ ಸೈಡ್ ಕೊಡು. ಇತ್ತತ್ತು ಕೊಡು. ಇಲ್ಲ ನಾನು ಹಂಗೆ ಸದಸ್ಯ ನೋಡು ಆಮೇಲೆ ನಿನ್ಗೆ. ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಯಾಕೆ ಇಷ್ಟು ದಿನ ಯಾಕೆ ಬರ್ಲಿಲ್ಲ? ಸೇಸ್ ಬಹಳಷ್ಟು ಕಾಂಪಿಟೇಷನ್ ಅದ, ಅದು ಮೇನ್ ಬ್ರಾಂಚ್ ಅದ. ನಿಮ್ಗೆಲ್ಲ ಗೌರ್ಮೆಂಟ್ ಜಾಬ್ಸ್ ಇರ್ತಾವ. ಕೇರ್ಫುಲ್ ಆಗಿ ಓದ್ರಿ, ಪರ್ಸೆಂಟೇಜ್ ಇಂಪಾರ್ಟೆಂಟ್. ಲೈಫ್ ಟೈಮ್ ಇರೋದು ಪರ್ಸೆಂಟೇಜ್, ನೆನ್ಪಿಟ್ಕೋರಿ. ಒಂದೊಂದು ಮಾರ್ಕ್ಸ್ ಇಂಪಾರ್ಟೆಂಟ್. ಕಂಪ್ಯೂಟರ್ ಟೀಚರ್ ಅಂತ ತಗೊಂಡ್ರೆ 70,000 80,000 ರೂಪಾಯಿ ಸ್ಯಾಲ್ರಿ ಅದ. ಗೌರ್ಮೆಂಟ್ ಸ್ಕೂಲ್ ಕಾಲೇಜ್ನಾಗ, ದೊಡ್ಡ ಡಿಗ್ರಿ ಕಾಲೇಜ್ನಾಗ ತಗೋತಿದಾರ. ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್ಗೆ ಫಸ್ಟ್ ಪ್ರಿಫರೆನ್ಸ್. ವಿಚಾರ ಮಾಡಿ ಓದ್ರಿ ಸ್ವಲ್ಪ. 3 ಸೆಮಿಸ್ಟರ್ ಓದ. Copied. This is the fixed question for 10 marks. You should remember. For writing the fourth question. Our subject is very easy, but the fixed questions are there. They will not change any. They will not have the any L level, L3 level, L4 level of questions here. Only L1 and L2 are the here. ಯಾರು ಫೇಲ್ ಆಗಲ್ಲ ಸಬ್ಜೆಕ್ಟ್. ಯಾರು ಸಬ್ಜೆಕ್ಟ್ ಫೇಲ್ ಆಗಲ್ಲ, ಅಟೆಂಡ್ ಆಗ್ಲಾರ್ದ್ರೆ ಫೇಲ್ ಆಗ್ತಾರೆ ಅಷ್ಟೇ. ಯಾವ Okay, I hope you all copied the things. Okay. Okay, yes, na? Okay, this is the model 10 course here. Whatever we are studying here, the writing of the programming. We are writing the program. Whatever we studied in the first one, this is all about the HDL programming, what type of HDL programming, and also evolution of HDL programming, and different types of defining the HDL programming in the different types of models are, and all these are all we studied. In the second module, we studied the what are those the data types and lexical conventions, and also system task and the declaration. These things, okay, whatever we study, those things are will be using in the writing a program. Our programming has to model, it should have the some structure. Okay, this is the one of the standard structure. Okay, this is the standard structure of writing the programming here. Okay, first part of this Verilog HDL model program, this is the upper part. This block mainly consists of what the model with the model name, and also it has the port list. Ports are nothing but the inputs outputs. Port are nothing but the input outputs. This is nothing but if any our digital system design, our DSDV always will have the inputs and outputs. Without inputs and outputs, we don't have the any digital systems here. That's the we have the port lists. These port lists are nothing but the inputs and also outputs, okay, and also port declaration. If it is necessary, then only we'll be using the will use the this port declaration if it is necessary. Some tasks, okay, which are to be used with the declaration of those particular ports only. Otherwise, will if you call them, will not work here in this programming. I have to define those. I have to declare those port declaration also, and also parameters. This is also one of the optional. This is the one of the optional. The compulsory is what the model name and the model name and port lists are the compulsory. We come immediately the end with the this model with the end model statement also. We should have this. These two are the compulsory, and this one is the body of this on model writing the programming. There are four types of writing the programming. One is what the first one is what the gate level or structural model. Another one is what the data flow model. Third one is the behavioral model. Fourth one is the switch level model. Switch level is nothing but the transistor level. This type of model they in electron students they will study in detail of the switches. That's nothing but the transistor level of programming. They will study each and every designing. They will study here. But for your syllabus we have the data flow model, behavioral model, and gate level model. The third model is itself is the what the gate level model. Fourth model is the behavioral model. And fifth model is what the that's the what the data flow model. Somewhat this type of model will be studying. For this one we have the some body here. Okay, each and every have the programming. We have the different types of body here. That's nothing but the first one. If I consider the first one is data flow statement. Yeah, I'll be using the in the data flow statement. I'll be using the assign keyword here. Which one? Assign keyword. If I use the data flow model always start with the statement with the assign keyword. Another, if you go with the study writing a programming with the gate level modeling ಗೆ ಅದು ತಗೋತೀನಿ assign keyword ತಗೋತೀನಿ. Okay, and also we have the behavioral model. Behavioral model always start with the always keyword at the rate of always begin with the and also end also. This type of blocks we have the inside the body, and also we will be declaration of the wires inputs. That's the wires are the nothing but the connection between the two gates or two digital systems, and also registers. This register keyword is used for the what that output the output of that particular digital system, and also some other variables also we will be defining here. And also if I use the ನಾನೇನಾದರೂ ಡೇಟಾ ಫ್ಲೋ ಮಾಡಲ್ ಮಾಡಿ ಬರೀತಿದ್ರೆ ಡೇಟಾ ಫ್ಲೋ ಮಾಡಲ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬರೀಬೇಕು. ಇಫ್ ಐ ಆಮ್ ಯೂಸಿಂಗ್ ದ ವಾಟ್ ದ ಟೈಪ್ ಆಫ್ ಗೇಟ್ ಲೆವೆಲ್ ಮಾಡಲಿಂಗ್, ದೆನ್ ಐ ಟು ರೈಟ್ ದ ಗೇಟ್ ಲೆವೆಲ್ ಮಾಡಲಿಂಗ್. If I use the behavior model, that type of, then I'll be using this type of blocks. And also we'll have the some tasks and functions, which nothing but the I have to perform with the some task. That's nothing but I have to work with the some task. Okay, that is to be declared with the help of the methods. Those to be methods. Here we call it the task and the functions. Here task and functions. This is all about the components of the Verilog HDL programming model. Verilog HDL programming model. Okay. If I consider the one example here, ಯಾವ್ದಾದ್ರು ಎಕ್ಸಾಂಪಲ್ ಬರಿಬಹುದು. ಕಂಪಲ್ಸರಿ ಯಾವ್ದು ಬುಕ್ ನೇ ಕೊಟ್ಟಿದ್ರೆ ಬರಿಬೇಕಂತೇನಿಲ್ಲ, ನಿಮ್ ಇಷ್ಟ ಬರಿಬಹುದು. ಬಟ್ ಫಾರ್ ಯುವರ್ ರೆಫರೆನ್ಸ್ ಪರ್ಪಸ್ ಐ ವಿಲ್ ಬಿ ರೈಟಿಂಗ್ ದ ಪ್ರೋಗ್ರಾಮ್ with the whatever in the book he has given mention, that one will I be writing here. What is this one? This is what the S bar. This is what the reset. Okay, this is what the Q. This is what the R. Sorry, Q bar. What is this one? This is what the SR latch. ಏನಂತಾರೆ ಇದಕ್ಕ? ಇದು ಯಾವ್ದು ಲ್ಯಾಚ್ ಅದ ಏನದ ಇದು? ಸ್ಟಡಿಡ್ ನೋ ಇನ್ ದ ಎಕ್ಸಾಮ್ ಇನ್ ದ SR latch ಏನದು ಇದು SR latch. This is what the set and reset, that's the SR latch. We have the okay for this my digital system design. I have to write the program in the whichever the type. Okay, there you can write the in the data flow model, or even you can also write the behavioral model also. Just I am considering the writing the program with the in the model. Okay, always start with the writing the program with the help of what the model at the end model also. Okay, model name can be here the whatever the things we can give the model name can be here SR latch. Model name is completed, end with the end model statement also we have given here written. But the I to define the inputs and output ports here. Which are those input ports? S bar and the R bar are the two inputs here. Output are what the Q and the Q bar are the two outputs are there. I to define these two inputs and outputs in the with the port list. While giving the port list, which are those port lists? You have to mention here the in the bracket that is to be what the port list as the Q bar, and also I have to mention here the S bar. Another one is what the R bar is there. This to be what the inputs and output here there. Okay, these are the inputs and outputs, and also I have to define these explicitly with the help of what the input keyword. Another one is what the output keyword also. What are those inputs here? What are the inputs? Mustaki? What are the inputs for my digital system here? This is my SR latch. I have the inputs and outputs also. Inputs are nothing but the S bar and the R bar are the inputs. I have to define the S bar and the R bar are the inputs here. Okay, and also output are what are those outputs? Q and the Q bar are there. Q and the Q bar are the two outputs, and also I have to write the some program. Okay, I am writing with the here the what are the structural model or gate level model. What type of gates these are? The AND gate or NAND gate? NAND gate. So that I have to mention the NAND. Okay, first NAND one is NAND gate with the first NAND gate is the N1. Another NAND gate is what the N2. We have to give the names. NAND N1, NAND N2. Okay, these two. Okay, over. Next I have to mention here the first output and the inputs. First NAND gate output is what this one? Q. I have to mention here the what the Q, and the input, what are those inputs for this one is the S bar and the Q bar. S bar is the from this line. Another one is the Q bar is the from this one. Okay, S bar and the and also Q bar. Okay, S bar and the Q bar. Okay, first NAND gate is over. Next, second NAND gate you consider the NAND N2. I have to mention with the give the inputs for this one as the R bar is the first input. Second input is what? Which one is this one? Q is the second input. First output baribeka. First output andre yav baribeku? Q bar. And input for this one is the R bar. And another one is what? The Q. Okay, Q. Okay, this is all about writing the program in the structural model or gate level modeling. Just to copy this one, this figure and this one also. Okay, don't write, just wait. A model is a don't copy this one. I am defining. A model is the basic building block in Verilog. A model is the basic building block in Verilog. First point, the model is the basic building block in Verilog. Second point, a model can be an element. A model can be an element. Right? Copy it. A model can be an element or collection of low-level design blocks. A model can be an element or collection of low-level lower level design blocks. It describes, full stop, it describes functionality of design. It describes functionality of design. A model in Verilog. Next point. ಬರ್ಕೋರೋ ಹಾ ಖಾಲಿ ಬಂದಿದೆ ಕಾಲೇಜ್ಗೆ ಹಾ right somewhere else. Don't keep. A model in Verilog consists of distinct parts. A model in the Verilog HDL. A model in Verilog HDL consists of distinct parts as shown in the figure above 1. Okay. Next, a model definition always start with the keyword. A model definition always start with the keyword. Always start with the keyword model. Model with the ಇದು ಬರ್ರಿ ಈ ತರ ಎರಡು ಹಾಕ್ರಿ ಮಾರ್ಕ್ ಡಬಲ್ ಕೋಟ್ ಹಾಕ್ರಿ. Okay, next one, the model name, comma, port list, comma, the model name, comma, port list, comma, port declarations, and optional parameters must be first in model definition, must be first in a model definition. Next, port list and the port declaration are present. Port list and port declarations are present only if the port list and port declarations are present only if the model has any ports, only if the model has any ports to interact with the external environment, Okay, here the inputs and the outputs are these two are the ports. Okay, we are defining. Okay, these are the interaction with the external environment through the giving the inputs, and also in order to get the outputs through what the output ports also. These Q and Q are the outputs here. Okay, next, the 5 components within the model are the 5 components within the model are model are first one is the Verilog variable declarations. First one is what? The variable declarations. First one is the variable declarations. Second one is the data flow statements. First one is this variable declaration. Second one is the data flow statements. Third one is the instantiations of lower model. You have to explain this one is the very in the words, that's it. Okay, nothing else. Instantiations of lower level models. Fourth one is the behavioral blocks. This is the always at rate of always, and instantiation block is for the behavioral statements. And fifth one is the task and functions. This is the task and the functions. This is the task and the functions. Okay, next point. These components can be any order. These components can be in any order. Okay, we can write declaration of the, this is the compulsory. We should have to define the first one, and this is the end. Most statement is the end only. In between, whatever we have the statements, we can be declare any. Okay, in the, it's not, we don't have any order for this one. We can write of your own wherever it is necessary. You can call these type of statements in the programming. Okay. These components can be in any order, and these components can be any order, in any order, and at any places, in the model definition, in the model definition. Next point. All components as model, comma, model name and end model are optional and can be mixed and matched as per the design needs, and can be mixed and matched as per the design needs, needs also. Okay, consider the example of an SR latch. Consider the example of SR latch. Understand the components of module. Okay, write this example figure SR latch. Just to copy this SR latch and also program also. This SR latch has the two inputs. One is the S bar and the another is the R bar, and also we have the two outputs, the Q and the Q bar. Okay, we have the two gates here. One is what, first NAND gate, another is the second NAND gate. What we are doing here, feeding back. Okay, output is always feedback to the given as the inputs to the another one. This one we use the as the memory. This is what the what type of sequential or non sequential. This is what the sequential logic circuits. This is what the sequential logic circuits. Okay, in the sequential logic circuits we have the SR latch itself. One example. Consider this example or copy this one. Okay. Okay, just I hope you copied this one. Just to copy this one. Okay, next SR latch can be modeled with the SR latch can be modeled with the gate level, with the structural or gate level model, as SR latch can be modeled with the gate level or structural model programming as, just to copy, model with the model name as the SR latch. Bracket, within the bracket you should have to mention the inputs. First outputs are inputs. Inputs are variable, output declaration. While declaration the ports we can define anywhere. Q and Q bar, these two are the outputs, and the S and S bar are the inputs. You have to define the first outputs, inputs. Next inputs, as which are those inputs are the S bar and the R bar are the inputs, and also output as the Q and the Q bar. Next. Okay, while writing the programming I used what the structural model or gate level model. Just I am looking at the figure, we have the name here. What type of gate we are having here? NAND gates. Just to mention that name itself as the NAND gate. NAND N1, NAND N2. Okay, you have to declare. So in this NAND gate, you should just look at the NAND gate. How many inputs for the NAND gates are those? Abhishek, how many inputs for this one? Huh? Abhishek, stand up. What are those inputs for the NAND gate here? Huh? Which are those? Or inputs? S bar and this one is the Q bar as the two inputs. Only one output is that one is the Q. Those things only I written here. First I have to define the Q as the output. Next S bar and the Q bar as the inputs. Similarly, I can go with the second AND gate. Second NAND gate which is having the two inputs, which are those? The R bar and the another one is the output of the first NAND gate, that is the Q. Okay, thus and the Q bar. I have to mention the first always with the output or input. Which one? Output ಬರಬೇಕಾ input ಬರಬೇಕು first? First output ಬರಬೇಕಪ್ಪ. and NAND early NAND into Q bar as the output of this the first second NAND gate, and also I have to mention the R bar and the Q are the inputs to the second NAND gate. This is what the writing the program in the structural model of the SR latch. Sit down, just to copy. ಬರ್ಕೋ ಫಸ್ಟ್ ಔಟ್ಪುಟ್ ಪೋರ್ಟ್ಸ್ ಬರೀಬೇಕು, ಆಮೇಲೆ ಇನ್ಪುಟ್ಸ್ ಬರೀಬೇಕು. ಜಸ್ಟ್ ಕಾಪಿ ದಟ್ ಒನ್. ಕಾಪಿಡ ಫಸ್ಟ್ ಔಟ್ಪುಟ್ ಡಿಕ್ಲರೇಷನ್ ಮಾಡಬೇಕು, ಆಮೇಲೆ ಇನ್ಪುಟ್ಸ್ ಪೋರ್ಟ್ಸ್ ನೇಮ್ ಬರೀಬೇಕು. ಆಲ್ವೇಸ್ ಯು ಶುಡ್ ರಿಮೆಂಬರ್. Okay, anyhow we declared, okay, anyhow written the program. Okay, I have to test whether my program is working properly or not. This is to be achieved with the help of what? Writing a program, that is to board the while giving the inputs in the combinations that we call the test bench. I have to write the test bench also. Just to write the try to write the test bench also here. Okay, Muhammad Kaif. Okay, this is what the my digital design system. Okay, what is the name of my DSDV? That's the SR latch. I designed my SR latch with the help of what the two NAND gates here. Whether my this digital system is working properly or not, how it is work, that is to be defined. This is with the help of what the programming. With the programming, I explained with the programming. So whatever I have written the program and also system design, it has to be work properly or not. Then I have to give the inputs. Okay, if I give the one input combination, that is not useful. Okay, it will be working or not. I have to give the input combinations here. How many input combinations I need here? Because of the two inputs here, how many combinations? 2 to the power of 2, how many? 4. That's nothing but the 4 inputs combinations I have to send. This is to be done with the help of what the writing a test bench. The writing of the test bench. Now see the how to write this test bench for the input combinations as the 0 0 0 1 1 0 1 1. I have to send this type of inputs combination for testing my digital system while giving this one. This is to be done achieved with the help of what? Writing the test bench program. Test bench program. Just to write the test bench program model stimulus. Module stimulus. Okay, I have to define here the outputs as the with the help of the register keyword, that's the reg, that's the output which are output of this one. Okay, first output of this one is what? The okay, that's nothing but the inputs are usually defined with the help of what? The wires, and outputs are usually defined with the help of what? The registers in the writing a program in the Verilog HDL. If I go with the same writing the program in the test bench, this is the opposite each other. Registers are used to define the inputs, and the wires are used to define what are the outputs. But in the Verilog HDL program, for writing the program in the any other model, I have the inputs I have to define with the wires, outputs are defined with the register keyword. But exactly opposite to this one will be using the in the test bench. Registers are used to define the inputs, and the wires are used to define the outputs here. Okay, just to write this one as the registers. What are the inputs for this one as the S bar and the R bar are the two inputs here. Okay. Just you copy this one. Okay, this is what the writing a test bench. We are giving the inputs with the not only single input we are giving here. We are sending the set of inputs for the two input combination. We have the set of combinations here the as 000110 combination. So I am sending testing my digital system design with the help of for the Verilog HDL. Sorry, a test bench here. Okay, this is my writing a test bench for the SR latch model with the stimulus. Stimulus is nothing but we are giving the simulations. Means nothing but we are getting the waveforms with the we are making this what the invert type. Okay, whatever the outputs are there, those to be what here the inputs. Whatever the inputs are there in the program, that is to be considered as the inputs. Okay, that's nothing but the register keyword used to define the outputs or in the programming, but here the test bench we are giving the inputs combination as the S bar and the what the R bar. Similarly, wires are used to declare what the inputs in the data flow programming, but writing in the test bench we are using the opposite, that's the wire as the Q and Q bar. Okay, next SR latch with the name as the and these are the inputs. Okay, what are those? Q and the Q bar are the outputs. I have to define the output and also set and reset. Set and reset. Set and resets are declared. Okay, bar. Okay, these are the bar. Okay, what we are having the bar? No, that is to be defined in what type? That's the tilde I am using here. What are those? Enole? Huh? Hey, are you able to sit here properly or not? Otherwise, you can leave. Move on. Whatever it may be. Okay, this is what the SRLH with the model name as the Q and Q bar as the outputs here, and set and reset are the inputs. Why I am using the tilde? Because of the bar. Bar I use no. Bar, that is nothing but the invert form. This was the invert form. Next initial block, and also initial block, that is nothing but the I am writing it. This is the behavioral type, and also begin and end. This is begin and this is the model, and also my end model here. Yeah, model and end model. So that I am sending the display purpose, that's the monitoring, that's the that's the system task. I'm using the dollar monitor, and also timestamp, that is nothing but the dollar time also, and also I'm using the set as the binary form, that is nothing but the B is nothing but the binary form, that is to be what the juror binary form. What are those binary forms? Juror, get up, stand up. What are the inputs combination for the binary? 0 or 1. Okay, for the two input combination, how many inputs combination I can have? 3. Wow, super. What are those? Huh? By tomorrow onwards, don't come to classroom, my class. Hey, shut up. You stand up. You stand up. You only sit down. You. Yes. You stand up. Why are you making noise here? ನೀನು ಕೂಡ್ಬೇಕನ್ನಿಸ್ತು ಕೂಡು, ಇಲ್ಲ ಎದ್ವರ್ಗು ಹೋಗು. ನಿನಗೇನು ಬಾ ಅಂತ ಕರ್ದಿಲ್ಲ. ನೀನ್ ಇಷ್ಟ ಇದ್ರ ಕೂಡು, ಇಲ್ಲಾಂದ್ರೆ ಎದ್ವರ್ಗು ಹೋಗು. ನಾನು ಏನಾದ್ರು ಹೇಳ್ತಿದ್ದಿಲ್ಲ ಅಂದ್ರೆ ಅದ್ ಮತ್ತೆ ಬೇರೆ. ನಾ ಹೇಳ್ತಾ ಇದ್ದೇನೆ ಇಲ್ಲ ಕ್ಲಾಸ, ಮತ್ತೆ ಯಾಕೆ ಡಿಸ್ಟರ್ಬ್ ಮಾಡ್ತಿದ್ಯಾ? ಬಂದದ್ದೇ ಇವತ್ತು ಫಸ್ಟ್ ಕ್ಲಾಸ್, ಮತ್ತೆ ಅದ್ರಾಗ ಬೇರೆ ನಾಟಕ. ಸುಮ್ ಕೂಡ್ರಿ, ಒಳ್ಳೆ ಹುಡುಗರು ಅನ್ಸ್ಕೊಂಡ್ರಿ ಇಸ್ತಿನ. ಈಗ ಹಿಂಗ್ ಮಾಡ್ತಿದ್ರ? ಬಂದವೇನು ಕೊಂಬ ತಲೆ ಮೇಲೆ? ಈಗ ಆಲ್ರೆಡಿ ಮುರಿದ ಅರ್ಧ, ಇನ್ನ ಪೂರ ಕಿತ್ತಾವ್ ಕೊಡ್ತೀವಿ ನಮ್ಮ. Okay, this is what the SRLH. We have the inputs and outputs here, and also we have the monitor timestamp also. This is what the set is nothing but the I have to set it either binary form, that's the 0 or 1. Just I have used the percentage of B. Percentage of B is nothing but the binary. That's nothing but the binary form. And also I have the input combination as the set as the 0, reset as the 1. Okay, 0 or 1. Just I am sending the input combination as the 0 0 0 0 0 1 1 0 1 1 combinations. I am sending here the input combinations as the 0 0 0 1 1 0 1 1. If I make the simulation waveform, if I generate the simulation waveform, definitely I will get the outputs for this input for this my digital system. Okay, digital system design can be designed in 3 ways. One is what the designing of the digital system using the gates, whatever the things. Then I have to check this my digital system design while writing the Verilog HDL program. Whether the inputs, I have to check whether the my programming is working properly or not. No, for one input it will take automatically, but I have to check the inputs combination because of the 2 inputs here. The 2 to the power of 2 means what the how many inputs? 4 inputs combination I check, so that I have to send set of inputs. I will be checking this output with the help of writing the test bench. This is our what the writing a test bench program for checking simulation waveforms. To get the simulation waveform, I am writing the test bench also. This is all about the writing a program. What this is all about the model and also defining the model, and also model explanation, and also explanation of the model with the one example, that is the SR latch. They will be asking you in the examination, you will be giving the directly this figure. Write a Verilog code for this HDL this digital system with the Verilog code and also test bench also. You should have to write these 3 things for the 6 marks. If you ask for the full 10 marks for the defining the model declaration and all. This comprehensive model you should have to explain theoretically and also give the example of these things also. At least you should have to write the 3 to 4 pages. Okay. Tomorrow we'll see the another concept. That one will continue by today. Okay, before I close this class, I want to tell you something. Okay, that's nothing but we have the one more announcement, because we have the Q Spider is coming on the next week or second week of this third week of this month, so that all are requested to read the one of the programming, whether it is a Python or whatever is the Java, your wish. Okay, should have to prepare that one. Okay, if you want that one, I will be sending the some videos and all links also I will be sending. But if you, before I come to the Q Spider drive, you all should have to come with the one introduction video, another one is resume, third one is what the just a minute topic also. We should have to thorough these three things while before I come to the Q Spider drive. Okay, we are expecting the Q Spider drives because the this 6th semester students are, we have seen the so many students are very intelligent compared to the other batches, earlier batches. Your batch is very good batch. Okay, I hope we are expecting from your side more than 40 students have to select in the Q Spider. Q Spider is might be, this is what the training and placement company, that is the, you might be thinking, but at least you should have to get the good idea, and you also commenting on what the attending the interviews and all. So I am requesting all you should have to prepare these things before coming to the Q Spider. And also in the next that is the Saturday, we will make the some groups here for 4 to 5 students group, and also remaining for 2 to 3 students will be adding. But for as per your wish, you can have the 5 members your friends in your group, but we'll give the 2 to 3 students from our side, because some few students are not coming to the classes regularly. Those students also giving in your sending them in your team, so that take care of your team and also take care of your friends for the attending the interviews and getting the job in future also. Okay, that's the my wish to all. You should have students from our college, you should all select the one, at least one company also you should have to select. If you are selected in the Q Spider, definitely even you will also allow for you attend the other companies also. Okay, you'll attend Q Spider select other bare company allow model compulsory, will allow for all the different types of companies also for your for attending the interviews also. Don't worry. 1, 2, 3, 4, 5, 4. 4 is there. ಅಭಿಷೇಕ, ನೀ ಹಿಂಗಾಗಿದ್ದೀಗ ಕೇಳಿಲೆ, ನೀ ಹಿಂಗಾಗ್ಲತ್ತದಿ, ಅದು ಹಂಗಾಗ್ಬಾರ್ದು ಅಷ್ಟೇ. 5, 6, 7, 8, 9, 10, 11, 12, 13, 11 ರೀ, 12, 13, 14, 15, 15, who's the 15? 15, 16, 17, 18, 19, 20, 21, 20, 17 is there, 22, 23, 24, 25, 26, 29, 30, 31, 32, 33, 35, 36, 37, 36 is there, 37, 38, 30, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, Thank you. Huh? Huh? 400. Why you writing this one? Where is Jazz? Varalanu college ka? Huh? Will not allow for him to second internal also.